The next method of heat transfer I want to talk about is going to be called convection. And in this type of heat transfer, the heat energy can be transferred from one object to another without any physical touch between the two objects. Instead, we're going to transfer the heat energy through a medium. Taking a look at this heating element submerged in water right here, obviously the heating element is going to be fairly hot. It's going to be touching the water. The water is going to be the fluid here, and the conduction of heat energy from the hot element to the water is going to heat up the water, so the water is going to get hot. And then you know the old expression, hot air is going to rise. Same thing with hot water. It's going to become less dense, it's going to rise up, and we can get heat flow through this system. So this heating element can heat up right over here, and it's not touching it, it's touching the water, and the water is touching the various parts of the tank here. The last form of heat transfer I want to talk about is going to be radiation. In that case, the objects don't have to be touching, and there doesn't have to be a medium between the two of them. You can think about the sun as emitting visible light, and you know that it's going to warm you up. It goes through outer space without a medium, so it's doing it using electromagnetic waves. It doesn't necessarily have to be visible light. If you get too close to your neighbor, you can feel the heat coming off of them, so it can be at wavelengths that we cannot necessarily see. How much heat flow comes off of a body is going to depend on several different things, so we can talk about the heat current from radiation, which again is going to be a flow of heat energy. That's going to be equal to the surface area of an object. It's going to be related to the emissivity. That's that little E right there. This emissivity is going to range between 0 and 1. Obviously, a body can't put off more heat than it contains, so it must be less than 1. It must be greater than 0. Having an emissivity of 0 means that the object is a very poor emitter. It's not going to emit any heat energy at all. Having a value of 1 means that the body is perfect at emitting heat energy. Typically, things that are white or shiny are going to have a emissivity close to 0. Things that are darker or black are going to have emissivity closer to 1. Real objects, it's usually somewhere in between. Then we're going to have a Stefan-Boltzmann constant. That's going to be this sigma, and that's going to be 5.67 times 10 to the negative 8th, and it's going to have a units, that's an 8 right there. It's going to have a unit of watts per meter squared Kelvin to the 4th. And lastly, it's going to be proportional to the temperature raised to the 4th power, and this temperature must be in Kelvin. So you can see if as the temperature gets lower and lower, an object's going to emit less and less radiation energy. You can see in this thermal imagery, this fellow, he's going to be, 98.6, he's going to be fairly hot. This Coke that he's drinking is going to be fairly cold, so he's going to emit a lot more radiation than his bottle of Coke right here. This expression for heat flow from radiation is also going to apply to absorption of heat energy in the form of radiation. If we consider my man from the previous slide drinking his Coke, the man's going to be at some temperature, so we can say that the heat flowing out of the man is going to be, area, emissivity of the man, Stefan-Boltzmann constant, and T to the 4th of the man. So he's going to be emitting some heat energy, but he's surrounded by an environment, and this environment is also at some temperature, so it's going to be emitting radiation, and the man's going to absorb this radiation. So we're going to have some temperature of the surroundings. The man is going to absorb some heat energy from his surroundings. It's going to depend on his surface area, his emissivity. The emissivity for absorption and radiation is going to be the same. Stefan Boltzmann constant, and then T to the fourth now of his surroundings. So we can now write the net heat flow out of the man to be equal to the area of the man, the emissivity, Stefan Boltzmann constant, and then the temperature of the man to the fourth, minus how much he absorbs back from his surroundings, so T to the fourth. You can kind of see if he's at the same temperature as his surroundings, the net heat flow out of the man is going to be 0. The same type of argument can be made for the Earth-Sun system. The Earth is going to have some temperature associated with it. It's going to be emitting radiation. It's going to be cooling the Earth off. This is mostly in the infrared, so we don't actually get to see it. It's also going to be receiving energy from the sun, and it turns out actually that having an atmosphere around us is a good thing. If we didn't have the atmosphere, we would radiate out quite a bit of our heat energy from the sun, and we would actually have a very, very cold planet. Our atmosphere is going to absorb some of the infrared radiation that the Earth is putting out, going to have a temperature of the surroundings, and it's going to re-radiate it back down towards the surface of the Earth, and it's going to warm up the surface of the Earth. This is actually a good thing. It's kind of how a greenhouse is going to work. However, if we change the constituents in the atmosphere such that they can absorb more infrared radiation and re-radiate more back down to the surface of the Earth, we could have an increase in the surface temperature of the Earth. The largest greenhouse gas is actually water vapor, but what people are worried about is CO2. That's something that we're emitting mainly from industrial sources. You can see how the CO2 emissions is generally rising from 1955 to the present, and people are concerned about the temperature anomaly as a function of year. You can see kind of from the 1950s the temperature is going up and up and up, so people are concerned about this greenhouse effect and how it could change the climate here on Earth.